Hi, my name is Ingus and I am the founder and owner of the company called IGS Electronics. Today we are going to do a follow-up video of uh, from the last video, which we were talking about single three-phase inverters, their basics and what they do. And today we are actually going to wire up and start reviewing the first of many drives that I'm going to do, which is a Yaskawa J1000 module on kilowatt rating of 0.75 for light loads and 0.55 for heavy loads. So I have already wired things up, and if you want to see how did we get to this kind of wiring and what's going on down there, please look at the video before about the basics of understanding single to three-phase inverter drives. So we already wired the drive up, so today we're going to look into the how we can operate this drive locally and see what time we got and how much time we got, and trying to get this all done in 10 minutes to go through for some basic parameters which would most commonly you will need to use, and what it can do and what it cannot do, and so other bits and pieces. So obviously before we start wiring everything up, we need to follow our trusty manual that comes from every manufacturer, from good manufacturer. They will always guide you through of what you need and what sort of cables to use, and everything else that you want to do with it. Is going to be this manual here is what they call the quick start guide. This is like a review quickly of how this drive can be operated, quick review of parameters and bits and pieces, and there's nowhere near as good as the full manual, which is this is like 36 page long, but the full manual is 230 pages long, where literally every single parameter is explained into very detail. So if you are into something like that, then definitely download the full manual rather than a quick start guide. If you are new to it and do want to know what each parameter means, I would strongly suggest you to do that. So you can learn quite a bit about it. So following along, so we have wired it up. So just quickly have a look. As you can see down there, I have my output coming out of the filter. And this situation, this case, I'm using a filter, and input is down there, single phase in. Obviously, don't ever forget your earth. Always earth everything as much as you can. And 3 phases from the motor coming out, set into delta, ready to go. So before power up, let's go quickly through the manual. And the first page we are going to come to, if you are installing your drive into the control panel or spacing and things like that, do follow these instructions because they are quite crucial of drive performance. So that's the first thing you should be looking into, and obviously read all the hazards and bits and pieces from the start if you do want to read it, if you've never done this before, just to get yourself familiarized of what you need to do and what is the manufacturer's guidance is. So this is the first thing if you're doing in enclosures. So do pay attention for the spacing, because that is vital for basically to be able to cool the drive. The next page, which is the bread and butter for everything you are going to do, is your drive's connections. It explains you in this little picture. It shows you what each bit means and what they do and how to connect it. Obviously, this is what they call the manufacturer's preset, and they are subject to changes, in which you'll be able to see in later on in a manual. You can change these inputs to different things you want to do with it, but this is what the manufacturer set this drive for, the basics, for basically their pre-settings. So this is the page you will able to see what is what. And these down here, these are your inputs. So it even says you forward, reverse, /stop down there, and then another one is external fault, reset fault, and then you can put another mode, the speed. And down here you can see you can put a potentiometer, they call the analog inputs. So they can be done with current, which is 0 to 20 milliamps, or you can use a voltage, which is 0 to 10 volts, which we will be looking into it in the next video when we be operating drive from not locally but remotely. So we'll be trying to set up several ways how can we connect this drive remotely rather than just pushing start and stop. So basically when it says local, everything has to be done from here. Press a run, press a stop. You can change the frequencies and all other bits that you want to do just from the drive, and that is not my preferred option to go, because unless you want an easy way, this is the easy way. Literally you can just get this going really quickly. But if you go externally, this is the way to go. This is explaining you exactly what each thing means. So that will be the review of your connections, and just a quick view of these guys here. That will be your alarms that you can pre-connect somewhere in case your drive trips or anything else happens, that you'll be able to see later on in a manual what you can do. You basically will set off alarms in case something happens or any faults appear in the drive. And down here you can use the analog output if you want to put a I don't know, display somewhere for the frequency you want to see, what frequency is running. If and then basically with this function down here, with these little connections, you can connect up your frequency meter, and you can put it anywhere you like. So let's go to the next parameters. In this page we can see the explanation of all the inputs, what they are and what they do. So read it through so you have familiarize yourself what is what. And in here we are finally on parameters. These are the core parameters you are going to be working with, and it has a brief explanation. As I said, this is a quick guide and not a full explanation guide. If you're looking for more explanation, you do need to go for full manual. So as you can see down there, it starts in here and it says the access level, which is A1, which is set already for 2, and then you initialize in parameters, which are no initialization. Then you can use a 2-wire or 3-wire initialization, which we will be covering in next video. My personal favorite is 3-wire, but I will show you in a video how to connect and how well it works and actually how does it work. So obviously then you set yourself a frequency reference selection. So what that is, basically you need to select where you want your frequency to work from. So if you review later on again for the more of a depth, we're going to go into the what was the word, remote connection. I'll be showing you what that selection does. But basically you change from the drive itself, you no longer are able to change your frequency from the drive. You have to use a potentiometer, and you can do it with the serial COM option, or as you see the potentiometer option, or analog input A1, which is the current version, which we are going to be reviewing at some point as well. Then obviously the run command, how you want to run it, as you can terminals, which are digital input, and again serial communication. So comms options basically control it from somewhere else, like PLCs and things like that. And stopping method selections, ramp to stop. Basically he uses the acceleration time to stop, and then coast to stop, it just lets the motor stop by himself. Then obviously the reverse operation, and then phase order. I don't usually touch that. There's no requirements at the brake. I never install. If I do ever need it, we'll definitely be reviewing that in some later videos. And again more injection, and then we go into the C1, O1 and C2, O2. These are your the acceleration and deceleration times. Again, acceleration is how fast it gets to the speed, and the acceleration how fast it slows down and stops. Those are your times, and then next ones is I never use them as well. Torque compensation, and then you can select down there duties, heavy or normal duty, and then you can carrier frequency selection. Don't really use that much, but basically alters the output a bit, and then it's depending how loud things are going for the drive. For the motor, you can alter that, and it will change the sound. But there is some consequences which I need to really read up to it if you start changing too much, too high. So and then you can set the multi-speed reference. It's actually got 1 to 8. I don't think this drive can do 1 to 8. I think we can do at least 4 different speeds. Again, we eventually at some point we're going to get to it and show you how multi-speeds can be used and what are their advantages. It could be very well for the lathes and things like that. The rest is just the input voltage set. What's the bloody saying? Input voltage settings, and then max frequency, minimum frequency, and so on. And then we need to enter down there motor data, which I said in the last video. If we watched it, if you use a different type of drive that is not the current that the motor is, you do need to enter the full data of what is what motor is rated. Slip in hertz. I don't ever done that before, but I don't think it makes much of a difference. Motor rated current, obviously, and motor no load current, motor line to line resistance. Don't use that. I usually just set what's the maximum motor current, so it stops when it goes over it, and the rest is just if you really want to get into there's a motor overloads you could set as well, which we are going to see in the menus in a minute. And then is all these bits that I very rarely get into it. Eventually we'll get to it, but at this stage I don't want, otherwise this video is going to take forever. So pretty much those were the key parameters we are going to be into quickly running through, otherwise this video is going to drag on forever. So let's power up this bike. So as we can see, all the power is done, everything is set. So we are going to run this drive today locally, which we're going to run it from buttons you see here. So let's plug it in. So just use almost the 13 amp plug as my ampage again on the drive. You can see down there, you already identified. Again, follow the manufacturer's guidance. What cable do you need to use? It's all there, and then we power up. So pretty much this state, as you can see, the buttons down there, you can see what each one of them do in a manual and how to operate it. So it's not rocket science down there. So right, as we are running this drive from local, we need to make sure all our settings are right to be able to run it from local. So first things first, as you see in the manual, we need to change the frequency reference selection to 0, which is a B001. So to go into the parameters, press down and press enter, and then you can go up to change the letters. So basically it has segregated everything into groups, so you don't have to like go from, later I'm going to be doing the Mitsubishi, you'll be able to see why. So we need B1-01, right? And we need to change that to 0. So we move it along, and we press enter to enter and we are already in 0, so that is fine. Save that. And the next thing, we need to make sure that our oh, not this page, this one, that our run command is set to 0 as well, as we are going to use run and stop keypads, and that is a B02. So we go up, enter, and our required command is need to operator is 0, so we need to change that. So move along down to 0, and as you can see, it changed the drive to local. So then we escape until it returns back to normal conditions, which they call the primary screen. And as we have that for the basic go ahead, that should be enough to get this drive going. So let's power up. So press run. As you can see, nothing is happening, but the run light is flashing. The motor is not running. Pretty much it's telling you is in the run command, but it's got no frequency being selected. So we just press the enter, and it's allowing you to change what you want. So we're going to go for 10 frequency, and we're not going to enter. So pretty much you can see now motor is running. To stop it, and then once you do that, accept, basically finalize, and then escape. And that's your frequency now for the motor running right now. So as we are using just the controls from the front panel, this is all we can pretty much do from here. We would have to always approach, start from the drive itself, and stop from the drive and change frequency in the drive. Pretty much that's what they call a local run. So let's go all the way to 50 Hertz. And as you can see, drive goes up slowly rather than all in one go. The reason it does that because your acceleration times is set to 10 seconds. So we will accelerate full speed in that 10-second interval, and if you press stop, it will slow down exactly in the same manner, 10-second interval. So that's pretty much the basics of starting and stopping the motor. And let's just go quickly escape that. We leave it for the 50 Hertz. So let's run it again, and you can see that it will takes its time to get the position. The acceleration times is usually set to your specific requirements. So I don't know, a lot of people use it for soft starts and things like that. So you don't have to use 10 seconds. It's just the factory pre-settings is 10. So let's go in the parameters and see if we can play a little bit with acceleration, deceleration time. Let's stop that. And as you can see, its dive is still flashing. It says I'm still deaccelerating, and when it stops flashing, it says the drive has fully stopped the motor, as you can see down there. And let me quickly go to acceleration deceleration settings, and I'll be back. So let's quickly run through this because this video is running long already. So deacceleration and acceleration is a C. 101 is acceleration. So let's get to it again. Parameters, down, enter. Change letter to C, which is C101, and then go along and enter it. And as you can see, we got 10 seconds. So let's change that to literally 2, my favorite. 2 seconds, and save it. Now let's see what happens. So let's start the drive. So as you can see now, it took him 2 seconds to get to the full speed. That's pretty much what acceleration deceleration does. You pretty much set up how you want your system to run, and where it starts and the stops. So I'm not going to get into the acceleration and other things like that. So pretty much you understand the basics of how to operate the little panel down there, and sort of understanding more or less of manual. We will be eventually getting more into depth of other things to drive, so basically, but we are looking into basics only at this stage. So with this little setup, you are pretty much ready to run any motor. And as you can see, as I said, Yaskawa quality drives are just impeccable. So the sound is pretty much non-existing. It runs very, very smooth, no noise, it's very quiet. It's got no fan, as it is capable of cooling himself down just alone. So that is a bonus. So well done for them to be able to design that so well. And in the next video we'll be looking at, start using something like this, and then more into emergency circuits, and then how to wire these safely, because this is a very basic setup. This is not a recommended setup, because you do have to follow the safety precautions in case things happens, and emergency systems needs to be put in, so to isolate the drive, and then other things that needs to be done, but not many people actually do it, especially people in the garage. They should. So I am gonna show you how to, and then if you want to do it. If you don't, well, it's entirely up to you. So this is basically the basics of how single to three-phase inverter Yaskawa J1000 is run from local. So let's stop this. As you can see, my stoppage time is going to take a lot longer because it's still on 10 seconds at the acceleration time. So this is the basics from local run of Yaskawa J1000 drive. This is a single phase. Obviously the same principle applies to three-phase drive. So thank you for watching, and I'll see you in the next video.